Another interesting physics application in practical scenario, when a car is trying to take a turn on a level horizontal road, it's a four-wheeler. So we'll assume that the center of the car or center of mass of the car, look at the diagram. So I'm going to say that the center of mass of that particular car is at a height h above the ground, and the wheelbase meaning the separation between the two wheels, that I'm taking it to be 2a. And let's say the car is taking a turn with a speed v. Radius of that particular circle, you can see the circle that's shown in the diagram. So let's say the radius of that particular circle over there, that radius is r, and the car is taking a turn on the horizontal ground. Now if we consider vertical equilibrium, we can say that n1 plus n2 will be equal to mg, first equation. And friction force acting on the two wheels, I'm calling that as F1 and F2. It should be towards the center, direction wise. It is that force which is providing a necessary centripetal force. So F1 plus F2, net physical force towards the center, that should be equal to mv square by r. And also limiting values of these forces, F1 cannot exceed mu n1 and F2 cannot exceed mu times n2. Now for rotational equilibrium, net torque about the center of the car should be 0. So that equation is written below, where F1, note that about the center, F1 will give rise to anti-clockwise torque, F2 also gives rise to anti-clockwise torque, N1 also gives rise to anti-clockwise torque. Sorry, clockwise, all these three clockwise. So F1, F2 and N1, all these three will give rise to clockwise torque about the center, whereas N2 will give anti-clockwise torque about the center. So sum of clockwise torques should be equal to anti-clockwise torque. We'll get this particular relationship. F1h plus F2h plus n1 into a should be equal to n2 into a. Using the idea of torque expressions, we write that. Now for no skidding of this particular car, if the car is not to skid, the sum of f1 f2 should not exceed the limiting values. Now f1 plus f2 from equation 2, you can see that mv square by r, that must be lesser than or equal to mu times mg, or maximum speed of the car for no skidding, that should be mu times rg. So this we have done previously in the case of cycle also. So anyhow, we have done it again. So here maximum speed is this much. Now if there is no overturning, additionally this condition should be satisfied, this torque rotational equilibrium. And also we know f1 plus f2 from equation 2 will be equal to mv square by r. So that equation over there, if we rearrange it, we will get mv square by r equal to n2 minus n1 times a. So we have two expressions like this. Now n1 plus n2 should be equal to mg, and also from this relation over here, we are going to get n2 minus n1 will be equal to mv square by r into h by a. Now you solve these two equations, you will get n1 value as this much and n2 value as this much. In fact, you don't have to remember these equations. Just you subtract these two equations, you will get n1 value, and if you add the two equations, you will get n2 value. So I have simplified it and written the expressions for n1 and n2. Now if the car is not to overturn, so just note, if v is 0, so if the car is at rest, you can simply put v value equal to 0, this term will vanish, this term will vanish, n1 will be mg by 2, n2 will be mg by 2, friction force will be 0, the car is simply going to be in equilibrium. Now as the speed keeps increasing, note that n1 value will keep on reducing. Eventually a particular speed will, if you keep on increasing the speed of the car, then this n1 can become 0 for a particular speed. N1 becoming 0 means what? So you go back and look at the car diagram. Now if n1 becomes 0, it means that this wheel over here has lifted off from the ground and the car is in danger of overturning. About this particular point, the car would overturn like that. If you keep on increasing the speed, n2 values will keep on increasing, n1 values will keep on decreasing. There will be a particular value of v for which n1 will become 0. So it is that maximum speed with which, in fact, we can say v square h divided by rga. This must be strictly lesser than 1 so that the car is in no danger of overturning. So v square must be lesser than rga divided by h. So if you have a lower height of center of mass, this term will become very high. r square g a by h if h value is very low, because h is in the denominator. So if you have a low height car, right, then v square can become more and more. The maximum speed, this should not exceed root of rga divided by h, where r is the radius in which the car is taking the turn, g you know, a is the half of wheelbase, and h is the height of center of mass. So this much speed if you exceed, then the car will overturn, right? So these are the two conditions of no overturning maximum speed and no skidding maximum speed. Another interesting physics principle where there is daily utility of right, physics ideas.